Hello, AP Calculus students, to another day of reviewing for the AP exam. First off, I just want to start off by saying that still no updates regarding the AP exam from College Board, though tonight there is a virtual meeting that a representative of College Board is holding to talk about how the AP exam is going to be looking like. And then tomorrow they're going to be releasing more of the general information to the public. So definitely look out for that. Let's get to today's bell ringer, and then we'll talk about what today's lesson entails. All right, so given that the limit of f of x as x approaches a is equal to a, which of the following statements must be true? Okay, so we can assume this capital A is just some number. So given that we know that the limit of this function is equal to this number, which of the following statements must be true? So let's look at some of these. So choice A, the limit of the function as x approaches a from the right is equal to the limit of the function as x approaches a from the left. So just a little recap, whenever you see this little plus or this little minus, where you would normally see an exponent, that's just telling you from which direction you're coming from. So this is coming from the right, so that's the positive side, and this is coming from the left because that is the negative side. So it's saying that they're approaching both the same values from the left and right. So we'll hold on to that one. B is f of small a equal to big A, so f of small a. So is the function value equal to the limit that's being approached? C is f continuous at small a. And then D, the limit of f of x as x approaches a from the right is not necessarily equal to a. So let's look at each of these. Let's try to eliminate some of them. So let's see. Let's do C first. So f is continuous at a. So if you remember what continuous means, continuous among other things, but if we were to boil it down, continuous means that your function value at a has to be equal to whatever the limit is at a. That is basically what continuity boils down to, even though there is a few more conditions that we'll talk about over the course of us reviewing for the AP exam. But this basically is saying that the y value has to be equal to whatever value the limit is approaching. Now, the easiest way to show that this doesn't have to be true is to draw a graph. So if I were to draw a graph here, if I were to just, a really simple one, so let's call that A. All right. And we'll say this is that capital A. So if we look at this graph, we'll see that f of a is a whole. F of a is a whole. So f of a is not defined, but the limit is equal to capital A because it is approaching from both the left and right capital A. So it's getting closer and closer to capital A, this graph is. Recall, with limits, we don't actually care if the function reaches that respective y value, just that it gets very, very close to it, in which case it does here. All right, so that's out. This is clearly, I just drew a graph that is not continuous at A, so that one's out. Okay, so now B is saying, does f of a equal A? Well, that's basically what we did for C as well. Does f of a equal what the limit is approaching? It does not. F of a, there's a whole, but the limit is equal to A because that is the y value that you're getting closer and closer to, that you're approaching. So B is out. So now let's look at A. Is the limit from the right equal to the limit from the left? Well, at least in this graph, it looks like it's true. So we'll hold off on that one and look at D. The limit of the function as x approaches a from the right is not necessarily equal to a. Well, if you notice A and D are basically opposites of one another. D is saying that the limit of f of x is not necessarily equal to a, while A, on the other hand, is basically saying that they are equal to a. So only one of these can be true. And it just so ends up that A has to be true. This goes back to one of the fundamental definitions of a limit. In order for a limit to exist, in order for it to equal a value, in this case capital A, the limit from the right has to be the same thing as the limit from the left, which in this graph that I drew, we have that situation, right? If we approach from the left, it's equal to capital A. If we approach from the right, it's equal to capital A. As opposed to, let's say we had a graph such as this. Let's use the same idea. We have a graph that does that, but let's say we have a graph that does this, so we'll call this A. As we see here, from the left, it approaches capital A, but from the right, it approaches a completely different Y value. We call that capital B, doesn't really matter. All we know is that it's different than capital A. So that is one of the fundamental bases of when a limit exists. A limit can only exist if the limit from the right is equal to the same thing as the limit from the left. So that is why A would have to be true for this problem. It would have to be true for this problem. So I picked this bell ringer for a reason, is because today's lesson is going to be focused on the very first unit of the curriculum, Unit 1, which was all about limits and a little bit of continuity in there as well. So the focus of today's lesson is going to be limits and continuity. So on the handout that I will be uploading, you'll see that I have a section there where I tell you to look at your days 1 through 15 notes. That was basically what Unit 1 encompassed, days 1 through 15. So if you look at your days 1 through 15 notes, you will see everything related to limits and continuity. So basically what I want you to do on your own is I want you to write down in that space the key ideas from that unit, whether it be definitions, whether it be conditions, maybe if you can find some stuff on your flashcards that you wrote down to limits. I want you to write down everything that you think is important in that box. Additionally, what I did was I posted on AP Classroom 18 multiple choice practice problems related just to Unit 1, so all about limits and continuity. And I want you to try out those 18 multiple choice questions. Now, I really encourage you to try them out because what I want to do is based upon the ones that people struggled with the most, so based upon the ones that students got, or based upon the ones that were answered incorrectly the most, what I want to do after we come back from break, so after next week, what I want to do in our first Google Meet is I want to go over those problems that most students answered incorrectly. So please try to do that by the time we come back from spring break. So you'll have, a good amount of time to do those 18 multiple choice problems. Please try to do that. Another thing you can do is in that space on the handout that I will upload, I do want you to write down any questions that you struggled with the most, just so that you can keep in mind that those were problems that stuck out to you, and that's another way we can possibly comment on those the next time we do a Google Meet after spring break. So once again, look through your days 1 through 15 notes. Hopefully you haven't thrown them away. If you have thrown them away, thankfully, I've posted all of them on Google Classroom. Write down all the key ideas that you think are important, definitions, theorems, all that stuff. And then I want you to try those 18 multiple choice problems that I posted on AP Classroom. And then in our first Google Meet after spring break, so you'll have until then to do it. I want us to go over some of those problems that people struggled with the most. I will count this as extra credit again. So if you do these 18 multiple choice problems, I will count it as extra credit. So that is your assignment until we come back from spring break. So I believe that's the 13th, if I'm not mistaken. Today's the 2nd, 3rd, 4th, 5th, 6th. Yeah, 13th. So please try that out. Otherwise, I hope everybody's doing well. I hope hopefully nobody's gotten sick. Hope you guys are making the most out of this situation that we're in. Otherwise, I will see you guys later.